In this video, we're going to take a look at the binomial distribution. And the first thing we're going to talk about are the assumptions and the formula. So the assumptions for the binomial distribution are 1, there are a fixed number of trials. 2, the observations are all independent. 3, each observation falls into one of two categories, and we'll call these categories successes or failures. 4, the probability of success is the same for each trial. And then our formula for binomial distribution is the probability that x is equal to k is equal to n choose k times p raised to the k times 1 minus p raised to the n minus k. And now, in this formula, n is equal to the number of trials, k is the number of successes, P is equal to the probability of success, and 1 minus P is the probability of failure. And sometimes we call 1 minus P Q. So if you see it as Q, that just represents 1 minus P. And now let's take a look at a couple of example problems. In the first example problem, it says if we repeatedly toss a balanced coin, then in the long run, it will come up heads about half of the time. But what is the probability that such a coin will come up heads exactly half of the time in 10 tosses? So the first thing I like to do is write down the formula and write down each variable we know. So here we have P of x is equal to k is equal to n choose k, p raised to the k, q to the n minus k. And here we know that the probability of success, and here we're going to deem a success when the coin comes up ahead, and the probability of success, so P in this case, is 1/2, and Q, which is equal to 1 minus P, is equal to 1 minus 1/2, which is also 1/2. And we know that N is equal to 10, the number of trials. They said we toss the coin 10 times. And K in this problem is 5, because if we get a head half the time, that means we're going to get 5 heads. So we're going to say K is equal to 5. And now we just need to plug everything into the formula and calculate. So we're going to say the probability that x is equal to 5 is equal to 10 choose 5. Probability of success is 1/2, so 1/2 or 0.5 if you prefer decimals, raised to the k, which is 5, and q, which was 1/2, raised to the 10 minus 5, which is also 5. And this is equal to, if we do 10 choose k, we get 252. And we should probably take a quick look at how we got that. Remember that n choose k is equal to n factorial divided by k factorial times n minus k factorial. So here in this problem, if we have 10 choose 5, then we set this up as 10 factorial divided by 5 factorial times 10 minus 5 factorial. Now there's also a way to do this in the calculator, which is what I did. So I typed in 10 into the calculator, and then I went into the math feature, and I went over to the probability button, clicked enter, and scrolled down to the NCR button, clicked enter, and then typed in 5, and then you hit enter, and it allows you to get this number through the calculator. You can also use the factorial feature on the calculator to get this number. But if you are going to do it by hand, this is how we did it by hand. And now back to the problem. We still have 1/2 raised to the 5th power times 1/2 And 10 minus 5 is also the fifth power. So this is equal to 252 times 1/2 to the 10th power. And I'm going to say that this is approximately equal to, because I rounded it, to 0.2461. So that's telling us there's approximately 24.61% chance that if we flip a coin 10 times that we'll get exactly 5 heads. And remember that this 10 choose K, this is telling us how many different ways that we can flip 5 heads. So that's what this represents in the formula. And then times the probability of success raised to the number of successes we wanted, times the probability of failure raised to the number of failures we were looking for. Let's look at the second example. We have, if we repeatedly roll a balanced die, then in the long run it will come up 4 about 1/6 of the time. But what is the probability that such a die will come up 4 exactly once in 6 rolls? So again, we'll start with the formula. And now I'm going to write down what each variable in this problem is. So n is equal to 6, because they tell us there's exactly 6 rolls. K is equal to 1. They want to know the probability that such a die will come up 4 exactly once. So in this problem, a success is going to be considered rolling a 4, and a failure is rolling any number except for a 4. P in this case is 1/6. The die has 1/6 chance of being 4 each time we roll it, which means that Q is equal to 5/6. And now let's plug each variable into the equation. So we have 6 choose 1, and then the probability of success is 1/6, and we're going to raise that to the 1 because that's the number of 4s we're looking to roll. And then Q is 5/6, and we're going to raise that to the 6 minus 1, or 5. So here we have 6 choose 1, and anytime you have any number choose 1, the answer is whatever n is. So here we're going to have 6 times 1/6, and then we have 5/6 raised to the 6 minus 1 is 5, and this is equal to 6 times 1/6 is 1, so we're left with 5/6 to the 5th, which is approximately equal to 0.4019. So the probability of rolling exactly 1 4 out of 6 rolls is approximately 40.19%. And that's all for this video on the binomial distribution.